But
we need to get our notes out.
yeah, you do need your notes out. We are taking notes. But we don't want to graph every single time. I know that we don't want to solve any of these anyway. But given that we have to, I don't even know where my textbook is. That's kind of annoying. Yeah, that's very annoying. Guess I'll use this one. Same stuff.
It's under that poster
Under the poster.
that I'm pointing at.
The chair cane.
On the stool.
Oh gosh, what?
Oh yeah, I knocked it over yesterday, I remember. And then I didn't pick it up.
Such a snake. Everyone's a snake today.
Man, I was born a snake.
Alright, so Chapter 7. I don't know why I'm recording me doing nothing. Okay, so systems of equations. We are going to go ahead and boom, we're going to solve by substitution. And the beauty of this is that we don't have to graph anything. So no graphing at all. We can do it all with algebra. But the downside, there's always a downside of this, is that it can get really, really ugly. So, solving by substitution. Let's go ahead and work. We're going to go through 3 examples, basically. And you need to make sure that you pay attention to what the heck is going on here. So we're going to start with the system, and rather than graph it, we're going to say, all right, here it is. Here's our system. Here's the idea of substitution. I wanted to walk you through the idea before we do it. So watch my thinking. I have 2 variables. So my thinking is I'm going to solve for one variable and then substitute into the other equation. So notice both of these are solved for which one?
Y.
They're both solved for y. Notice that they both say y equals something. So I'm going to take this stuff and say, well, if y equals this stuff, put that stuff in place of y. Do you see what I'm saying? So I'm going to rewrite this as x plus 4 equals 3x. Pop your hand up if you don't understand what I just did right there. Did you follow along with that? I said y equals both these things, so I'm going to take that stuff and put it in for y in the other one. It doesn't matter which variable it is or which equation I do that to. Now what?
Solve it.
Solve it. Solve it like normal. So I subtract my x, and I get 4 equals 2x, and now what?
Divide.
Divide by
2.
2, and x equals 2. But that's only half my answer. Remember I talked about half answers yesterday? That's half my answer. I need to find x and y. Anyone have an idea how I can find y now that I have x?
Substitute.
Yeah, substitute it. Hence the word substitution. We're just going to substitute twice. First I take a whole equation and substitute it, then I take my answer and substitute it in. Now it doesn't matter which one I put it in. In this case I'll take my 2 and I'll just put it into this one right here. So y equals 2 plus 4. Now pop your hand up if you don't understand what I just did there. Okay, y equals 6. So what's my answer? 2, 6. Now it's possible that you don't have x's and y's. If I had a's and b's, what order do I put my numbers? Alphabetical. So if I had a's and b's, a would go first and b would go second. Alright, go ahead and get that down. And now we're going to do one that's a lot harder. Or at least somewhat harder. How about that? Somewhat harder. Alright, you ready? Here's our next example. Let's say I have y equals x minus 7. And this time 2x plus y equals 8. Now this time, both of them aren't solved for y. But that ultimately doesn't matter. Okay? This one's solved for y, isn't it? And I can take all this stuff and put it in for y right here, right? Do you see what I'm doing? So what am I going to write? 2x what? Plus x minus 7, right? I just replaced that y with that quantity. Now what do I do?
Subtract x.
Well, before I do that,
Add 7.
I could add the 7.
Why don't you add the x?
I would, yeah, that's what I would actually do first. I would go ahead and add the 2x and the x and get 3x. Do you see what she's saying there? When they're on the same side of the equation, I could combine them. And now I'm going to divide by 3. So x equals
5.
5. But that is not my final answer. I need to take that and put, now I can put it into either one and then solve for y. I'm just going to put it in the first one. Why would I do the first one? Because it's already solved for y. You see what I mean? I took this 5 and I put it in for x right here. So y equals 5 minus 7, which is negative 2. So my answer is 5, comma, negative 2.
Wait. Oh.
Did I do it wrong?
Never mind, I was in the wrong one.
And then I finally boxed that. Let's go a step harder. They don't give me any very hard. Well, there's a very hard one. Yeah, let's do that. I like that. Do we have this one? Any questions? Next example. Okay, so here's our next example. And notice this time, is anything solved for y or x? No. And my examples have just been y, just because there's no reason. It could be x that is solved for first, but in this case, neither of them. So what I need to do here is I choose one equation and solve for one variable. And my choices here don't matter. But in principle, I want to go with the easiest. So this is just a matter of opinion, really, which is the easiest. But I think the negative 5x plus y is going to be easier. And I think it's going to be easier to solve for y. So you see what I did? I chose one equation and I solved for one variable. It does not matter which one. Alright, so I chose the y. I'm going to add the 5x. Now I can't do 6 plus 5x, so I get y equals 5x plus 6. Now that one's solved for y, isn't it? Now what do? I plug it into the other equation, so that's going to be the next step. Take that quantity. And plug into the other equation. So I'm going to take this 5x plus 6 and put it in for what? In the other equation. And that's important. It has to go into the other equation. So what will I write? 2x minus 3. Now I need to be careful. Put this in parentheses. And what's going into parentheses?
5x plus 6.
And that's going to equal 60. Now, what should I do first?
Distribute.
Distribute a negative 3. Watch your negative. So I get negative 15x minus 18 equals 60. Now, what's 2 minus 15?
Negative 13.
Negative 13x. Now what?
Add 18.
So I get 78. Now what?
Divide by 13.
Negative 13.
Negative 13.
And x equals how much?
6.
Negative 6, maybe? Now what do I do? What's going to be our final step now? I have my x. I'm going to take that answer and substitute back into step 1. So I'm going to take this 6, and I'm going to go all the way up here, and I'm going to put it in there. I could put it into the original ones, but then I'm going to end up moving it over here anyway. So I'm just saving myself some time. So do you see what I mean? This work is going to take a lot of space, and it's going to get really sloppy. So I would leave some space here. Y equals 5 times negative 6 plus 6. And in the end, I get y equals negative 24. So what's my answer? Negative 6, negative 24. So we're going to do one more example together, and then you're going to actually start on your homework. So that if you have any questions or problems, that you can go ahead and get some help. I'm going to show you on the next example how I would recommend that you show your work on your homework, because I haven't really done it that way on this, the way I would recommend that you show it. So let's go ahead and do it the nice and organized way. Let's see if I can find a hard one. This one's hard. Looks harder. So we'll do this one. Here's our problem. So our book will give us 2 equations. For now, we get 2 equations. What? You mean I'm going to get more? A z, maybe? Yeah, we can do it with a z. Not yet, though. Why a z? Why not an x or a w? Okay. So I choose one equation to work with and solve for one variable. Which one looks to be easier?
5x plus 6.
I mean, we could do that one, but that one looks like it'll be really nasty.
Okay.
This one, this second one. So I'm going to choose that one. So in my work, I'm going to take the one that I'm going to choose to work with, and what variable would we solve for?
X.
X. We could, I mean, it doesn't matter, but x is going to be easier because all I have to do is subtract 2y, don't I? So x equals negative 2y minus 44. Now, what do I do with that? So I worked with that first equation. I'd put the second equation over here, that 5x plus 6y on the right equals negative 76. And I'm going to take this and put it in for x right here. So I'm going to write 5 times negative 2y minus 44 plus 6y equals negative 76. Do you see what I did? I'm not hearing any.
Yes.
Okay. So now we distribute that 5. I get negative 10y. Oh boy. This is why you have a calculator. 5 times negative 44. What's that?
Isn't that negative 200?
Sure. Plus 6y. I'll take it that is correct. Until someone proves that wrong. Okay. Now, do you see how these y's are on the same side? I go ahead and combine them, get negative 4y.
She's right.
Confirmed. We'll add the 220. So negative 4y, what's negative 76 plus 220?
Huh?
Well, I'm adding 220, so I have this negative 76 plus the 220.
144.
And then we're going to divide by negative 4 and get what?
Negative 36.
Now, often what happens with these long problems is you get one answer and then you never go back and get the next part. I need to go back and put this in for y over here. Do you see how I'm ordering the work? It's going to be very easy to follow, like relatively easy to follow.
Do we need to put the arrows?
You do not have to, no. I'm just putting them so that you see where all this stuff is going. So x equals 72 minus 44. What's 72 minus 44? Alright, that's my half answer. And then somewhere down here, I will just box my final answer. 28, negative 36. So that's where thank goodness I didn't have to graph that. That would be an awfully big graph. Okay? Alright, I want you to turn in your books to page 350 and go ahead and take out a piece of paper that you'll use for your homework.